Welcome. In this video, we'll learn about building a decision classifier. A decision tree is a structure that allows us to split the dataset into branches and then make simple decisions at each level. This will allow us to arrive at final decision by walking down the tree. First, let's see the output. For that, let's open my directory, which is building a decision classifier. Let's open the terminal and change directory to decision tree classifier. Type ls command and you can see all the files. I'll sure explain what these all files are. First, let's run the command as python space decisiontree.py. The first window shows visualization of the input data we have given. The second window shows classifier boundaries on the test dataset. So the boundary you can see black, here they are colored, and the output is printed on terminal. Here the performance of classifier is characterized by precision, recall, and F1 score. You can see it has a label also, that is class 0 and class 1, as the input data had some labels. Let me explain what this precision, recall, and F1 score stands for. The precision refers to the accuracy of classification, and recall refers to number of items that were retrieved as percentage of overall number of items that were supposed to be retrieved. A good classifier will have high precision and high recall, but it is usually a trade-off between the two. Hence we have F1 score to characterize it. The F1 score is the harmonic mean of precision and recall, which gives it a good balance between precision and recall values. So here you can see I have first one is training dataset and the second separated with the hashes is test dataset. So we basically divided the solution into two forms, that is training dataset and test dataset. I hope you got idea that how we divided the output into two ways, that is training dataset and test dataset, which I had said in the definition at the beginning. That is, a decision tree is a structure that allows us to split the dataset into branches and then make simple decision at each level. And this will allow us to arrive at the final decision by walking down the tree. So this is what we are going to do. So first let's see the code. Let's open my directory. So here is utilities.py. It contains all supportive module to the set. It has variety of support files in it. So this is a code which will give us the output, that is, it will give us a plot figure, that is the final output graph, which was a colored one. Now let's open the main script, that is decisiontree.py. So here the first one is import numpy as np, which we know it, and the second matplotlib, this also we know it, and the next is sklearn, this also we know it, but the new one here is import decision tree classifier and classification report cross validation. Now let's import the utility module in it. If you don't remember what is utility module, the code which had shown at the beginning, that is utility module. So for that, from utilities import visualize classifier. As we will be using the data in the data decision trees.txt file that's provided to you in this file, each line contains comma separated values. The first two values correspond to the input data, that is xy value, and the last value corresponds to the target label, that is 0 and 1, as you can see here. So I have written here input file equals to data decision tree.txt to load the data from the file data equals to np.loadtxt input file delimiter. So my data is separated by comma values. Now let's separate the input data into two classes based on label. So the label were 0 and 1 and were assigned into y. So here 0, 1 comparison, class 0 and class 1. Now let's visualize the input data using scatter plot. So this one, that is plot.figure, plot.title, input data. So this will give the first graph that is on input data. Now split the data into training and testing data set. So x train, x test, and again y train, y test, cross validation. This I had imported, that is cross validation, and train test split it among train and test values. Now create, build and visualize a decision tree classifier based on training data set. The random state parameter refers to the seed used by a random number generator required for initialization of the decision tree classification algorithm. The max depth parameter refers to the maximum depth of tree that we want to construct. The depth is 4. Now compute the output of classifier on test dataset and visualize it. Before we did of train dataset, here test dataset, it is y test, and visualize classifier of test dataset. Now let's evaluate the performance of classifier by printing classification report for training dataset. So class name, class 0 and class 1, print. So here this hashes 40 times to just create a column which you saw in the output, and print classifier performance on training dataset, print all the values of training dataset, that is support y train classifier predict x train target names equal to class names. So this output will give us the precision recall. So this statement will give us the output for precision recall and F1 score and the support. And the same for test dataset, that is to evaluate the performance of classifier by printing classification report for test dataset, which had said the first y train is precision and y test spread is recall and target names and class names. And finally show the plot values to the output, that is plot.show. Now let's move to the output again. Let's open the terminal and change directory to decision tree classifier. Type ls command and see your all files. Run the command as python space decisiontree.py. The first window shows visualization of input data. The second window shows the classifier boundaries on the test data set. The output is printed on the terminal. As I said before, the performance of classifier is characterized by precision, recall, and F1 score. The precision refers to accuracy of classification and recall refers to number of items that are retrieved as a percentage of the overall number of items that were supposed to be retrieved. A good classifier will have high precision and high recall, but is usually a trade-off between the two. Hence we have F1 score to characterize it. F1 score is the harmonic mean of precision and recall, which gives it a good balance between the precision and recall values. I did my best to explain this code on building a decision tree classifier. The main basic thing you have to remember here is that a decision tree is a structure that allows us to split the data set into branches and then make a simple decision at each level. So that's it in this video on building a decision tree classifier. If you didn't get the video, please do watch the video again. Thank you for watching this video.